My name's Corey Quinn. My Twitter handle's up there. Please feel free to tweet at me as we go along. Quick show of hands. Who here runs Docker? In production. Right. Okay, you've all heard about Docker because the first rule of Docker is never shut the hell up about Docker. So I'm sorry to disappoint you, but I'm not going to talk about Docker today. This talk is now called That Time My Boss Destroyed a Cubicle. And this is a completely true story. So let me take you back in time a decade. This was my first gig as a Linux admin, and my new boss had just started. He was doing everything you're supposed to do when you start a job. He was dressing well, which, respect, getting in shape, and he was hoping to make a strong first impression. Given the title of this talk, you can safely assume that he did. So one morning, we wind up hearing the strangest noise in the cubicle farm. It sounded a bit like shuka, 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 poof, which is not something you generally hear in an office. So we all prairie dog over the side of our cubicle walls, and what we see, well, let's back up a second. In order to understand what it is that we saw, you really have to first understand what caused that noise. In order to hit his fitness goals, my boss was making a lot of protein shakes, which is a poor idea, because if you change your body composition enough, your suits don't fit right. But protein shakes it was due to poor life choices, and he was also caffeinating rather heavily as he went through this process. So in order to save time, like a good ops person, he figured he'd start mixing the two inside of a sealed Tupperware container that didn't really have an outgas valve. Now, if you learn nothing else from this talk today, just take this one with you. If you mix Slim Fast powder with coffee in a sealed environment, it generates pressure, a lot of pressure. Enough pressure to blow the lid off of a Tupperware container. So, yeah, that pretty much catches us up to where we were in the story. So, we peer over the side of the cubicle wall, and we just see a complete disaster area. All over his clothes, computer, desk, keyboard, and of course, himself. And he stands there with the most forlorn, shocked, dismayed, and embarrassed expression on his face. And a year later, when I left the job, that chocolate blast ring was still there. So, fun story, but what's the point? How is it really relevant to anything that we're talking about at a conference today? I mean, it's really just a story about someone who didn't fully understand the potential failure modes of his container in production. And there's the metaphor. Now, my point in this talk is not to tear down a promising technology that people are jumping onto. It's fantastic. It really is, soup to nuts. What I want to talk about, though, is some of the things people tend to not consider as you start putting something like Docker into production. For example, I use Docker myself for another talk that I give on Git to give live demos. I didn't give a demo for this talk because I couldn't find a Tupperware container. So why is Docker in production something of a challenge? Before we get into why it tends to fall down in some scenarios, let's talk about what it is first. Docker is a relatively new container technology that Fortune 100s are going crazy over like a bunch of 19-year-old kids on spring break in Mexico. Why? Great question. It's because Docker is not only the best container technology out there, it is also the first ever operating system level containerization technology. This has never been done before. Well, technically it did at least originally ride on top of LXC, which has been built into the Linux kernel for a decade, but Docker did leverage and in turn popularize this. And Solaris zones were also around for a long time first. Funny story, when I built this talk originally a few months ago, this was a great joke. Someone since then has extended Docker so that it can now manage Solaris zones. I don't know who's trolling who anymore. But yeah, other than that, there really were no other operating system level containerization methods. So fundamentally, these all tend to get you a little bit closer, and I think Vagrant probably got closest of all before Docker came out to the dream of, I just wrote some code and it's awesome, how can I run it in an environment that looks an awful lot like production? Which is great, but we've been trending in this direction a long time. What makes Docker so notable compared to all of the rest of these? These have all had various bits of the hype cycle as well. Why is Docker taking off? On a completely unrelated note, Docker has raised $180 million across 4 rounds of funding from these 10 investors so far. I'm certain almost none of that was spent on marketing and building up hype around it. Now, once upon a time, back in the good old days, we had what we would call a 3-tiered architecture. This is from the Stone Age, also known as about 3 years ago, where you had something known as a web tier, an application or job tier, depending upon nomenclature in your shop, and a data tier. And at this point, systems were deterministically placed. You knew where they were. When something started misbehaving, you knew where to go look for it. And things were segregated out in logical ways. Oh, the app tier is being slow. I know how I'm going to go find that and fix it. Now with Docker, we're undergoing a bit of a tectonic shift to what's termed microservices-based architectures, where things live wherever they wind up being scheduled, and there's really no guarantee that they're not going to move around at any given point. Unfortunately, just making a cutover to microservices itself is not going to save you from your own poor decisions, but it does let you kick the architectural can down the road a few years until something else comes along to save you, or, let's be realistic, you get to change jobs. Because this is where it starts, it's not where it ends. So the challenge you run into is strapping this into your servers as they stand as bare metal doesn't quite work. Because generally, you make certain assumptions in this type of environment, that your system itself can call out to its environment with API calls. It can change aspects about its environment. Think membership and load balancers as a quick for instance. So underneath it, you need to run something else, like AWS, which runs on money, or OpenStack, which runs on confusion. I didn't make this up. This is an official OpenStack architecture diagram. This is why you'll see me drinking heavily for the rest of this conference. I'm kidding. They're going to totally throw me out at the end of this one. So now you've got this layer of unclear complexity riding on top of another layer of unclear complexity, all in the name of chasing a modern systems architecture. It's confusing as hell. It's like a Brexit. I'm sorry, was that too soon? And it's really a sad state of affairs. Weep for the state of DevOps, and weep for the sad puppy with chocolate and Slim Fast semi-permanently stuck in his fur because we're never getting it out of there. But how did we get to this point in the first place? The promise inherent to both DevOps and by extension Docker was that it makes development look just like production. It's a high-fidelity copy of each. This is the model that Docker espoused when they started talking in depth about what the model looked like. Think of it like shipping containers. You don't necessarily care what's crammed into a container, whether it's grain, whether it's electronics, whether it's a bunch of small animals for resale in seedy pet stores. It doesn't matter, because once it's in the container, you treat all of these containers the same way, and you ship them around using ships, boats, trains, 18-wheelers, I suppose, and everything just makes sense. So now you don't have to worry about what's inside. And this works really well, because you wind up with the idea that development and production look identical. You have Docker running in both places. You've solved for the works for me problem really well. Except you don't have to schedule containers on your laptop. They just live on your laptop. And Kubernetes or Mesos and whatever awesome sponsors we have that are making these things easier can't entirely occlude the fact that this is relatively non-straightforward to wind up implementing. It's heavy, it's complex, it's the focus of a lot of work around this. Even Docker just recently this week started talking about orchestration much more seriously than they had in years past. But this is the next frontier, is how do you schedule these things? If you have good ideas on how to schedule these things, please reach out to these 10 investors immediately. They would love to speak with you. Opportunity is on line one. Which brings us up to our next challenge, is networking. You don't usually see a whole lot of people talking extensively about networking in a Docker environment in the same way that most people generally don't tend to talk about exactly what happens on the kill floor of a slaughterhouse. It's not pretty, it's far from straightforward, and it's not the type of thing that is easily understood without a very thorough understanding of multiple layers of the stack all at once. We're working on it has more or less been the answer to a number of relatively serious challenges in this space. And it's still relatively slow, it's still fairly arcane, and it still just works when it's on my laptop. So let's make it worse. In most environments that are legacy, you don't wind up doing a knife switch cutover from the old environment to the new environment when you release a new version of your code. You wind up doing a staggered migration. Sometimes you'll pull a leg out of a load balancer, update it in place, run some quick tests on it, put it back in. Maybe you'll have one instance running your new version of code and you instrument the living hell out of it, which is called canary analysis. If error rates spike, you roll it back. If not, you continue rolling forward. There are a lot of different approaches that may work for this, often complicated by things like schema migrations, where very often you aren't able to roll back the same way to what you had before because now the data store has changed. Now, everyone has their own special snowflake unicorn way of dealing with these types of changes that most of our shops have spent significant time and energy investing in. The problem is that when you throw this away in favor of moving into a new deployment paradigm, it's not just about how you get the code into production, it's what those migrations and deployments look like. You effectively get to solve the problem you've already solved differently. There's not going to be a straightforward carry forward in this case. So it's possible to solve, but it's overhead, additional overhead. And all the work that you've already put into solving this problem has just become effectively obsolete. And if you're responsible for running this in production, your problems have really just begun. Has anyone here ever managed to monitor an immutable infrastructure environment to a point where they were completely confident in that they knew exactly what was going on? I see a couple people half raising their hands. Good, it's possible. The problem is that there are serious challenges with the way we think about monitoring and the way that we wind up thinking about immutable ephemeral infrastructure. If a system stops working or becomes slow or experiences an intermittent problem, how do you get sufficient data out of that container in such a way that by the time you're aware of the problem, the instance itself no longer exists? So everything that it's put out, you need to be able to instrument and have insight and visibility into. And again, traditional things such as Nagios or any other monitoring system that depends heavily upon specific host names, that's going out the window as well, because you're going to see randomly generated host names and suddenly your graphs look like hell when you have 20,000 entries on it. And tied heavily into monitoring is the concept of supervision. When you have process and container supervision, it becomes a tricky thing because Docker does handle this reasonably well. But sometimes processes die. That's the nature of our crappy code. And there's a giant pile of tooling that exists in the world that enable us to make sure that that doesn't happen. Or if it does, it comes back quickly. Now, Docker addresses this. And so does Supervisor D. And so do 3 other different kinds of tooling to handle this. And there's a multiplicity of options in this space. But the reason that this is starting to become an issue of concern is that by the time that you've solved for everything so far in this stack, you're rapidly approaching having built something that doesn't mirror what other shops are doing even slightly. Which means that when there are problems, and speaking as someone who's been doing ops for way too long, there's going to be a problem someday, you need to be able to hold the entire thing in your head and intelligently understand how these things work. The ability to go out and get the answer off of Stack Overflow becomes more and more challenging the higher you diverge from what a lot of other shops are doing. And again, just as a reminder, none of these things so far are even on the horizon when you're doing local development on your laptop. Now, historically, I was always focused on configuration management. It's where I cut my teeth. It was something I got very good at just in time for the world to go immutable. Huzzah. Now, Docker is increasingly starting to position themselves as an answer to configuration management. I do respect the perspective. They are wrong. It is not configuration management. It doesn't work the way you hope it would. For an example, I spin up a Docker container in an environment, whether it's my laptop, whether it's staging, whether it's production. how do I tell that which load balancer to associate itself with? How do I tell it which data store to work on? How do I tell it whether or not it's in production or development so that it can, for example, adjust the verbosity of the logging, put itself into debug mode? I mean, there are challenges here. I mean, what do? Do you run a configuration management agent inside of a Docker container? That was rhetorical. The answer is no. No, you do not do that. So there are solutions here, and additionally, even if you were to do that, with every modern configuration management system, registration and deregistration of ephemeral things that are short-lived is not a simple problem either. So even if you decide to go in a terrible direction, it still winds up not being straightforward or easy. And again, everything you're doing here still has to be able to respond effectively to the whole idea of rolling deployments. What I'm really starting to speak to here is the sense of either peer or service discovery, where containers need to be able to talk to one another, where through stabilized and defined API endpoints, they need to figure out where the master database lives. For example, when you have that node living in production versus staging, you probably want it using different database endpoints, and Lord, I hope you want them to have different credential sets as well. How do you securely get that information to nodes? There are a lot of answers in this space. You've got Consul, Zookeeper, etcd, Redis, Mongo. The time I abused my SQLD so badly that I'm still not allowed within 500 yards of an actual relational database. DNS, Pillar, Sensu, a few more. What time does the bar open? Because I could really use one right about now. None of these things are straightforward, and they all have failure modes that are hard to solve for. So let's keep climbing up Mount Hopeless here. So you've built an awesome container. Great. How do we get to a point where you're storing it somewhere that I can safely take that container from you and put it into production in a repeatable way? And this is interesting because most shops of significant size or significant paranoia do view the code that they're running as a trade secret, and they don't want this on the public Docker hub, which makes sense. So Docker does offer private registries and private hubs. That was one of their very early business models, where pricing started at $150 a month, scaling all the way up to, would you like to buy us? And that was great. It was an awesome approach, following something of the GitHub model. And then Amazon came out and offered a very similar hosting service at 10 cents a gigabyte, scaling forever. And that's not an unreasonable price point, and it scales very linearly. And unless you're doing something truly bizarre and frightening, it means that paying to store your Docker images in a way doesn't become a problem. Unlike anything else that I'm talking about in this talk, I don't have a problem with that. But a lot of people do, specifically because Amazon is a terrifying competitor, because they have massive scale, massive money, and they don't play to win. They play to break even, which means that you've got to start rethinking what you're starting to offer in this space. It makes them profoundly dangerous if you're starting to offer something like this, either as a platform or a service offering in the infrastructure space. Okay, so we're almost out of room on the slide, thank God. And let's say that another group in my company, or another company entirely, hands me a Docker container, where it becomes very hard for me to audit that container, specifically how it was built, where it came from, what was the decision-making process by which they picked certain settings. I'm not even saying that this Mongo container you gave me is bad. What I am suggesting is, how do I validate that I agree with the setup steps that were taken, and does that setup process and opinionated design make sense for the way I'm going to use it? It becomes dangerously close to the idea of, oh, don't worry about it, it's fine. I've seen a number of different talks so far on how to properly build containers, and there is one glorious shining consensus from all of them. All of those other talks are wrong. So all I have to go on is that my developer is telling me, oh, it's fine, I wrote it last night, and it's great, put it in production immediately. So when it breaks at 3 in the morning, because things never break when you're awake to deal with them, you're in what is going on here territory, and there's a failure of the trust model that comes attendant with that. All of which ties into security, which completes the list. I put security at the end because it's one of those nice-to-haves that you can finally bolt on later after you've done everything else. Yeah, you folks laugh. At RSA, they didn't laugh. So let's pretend for a second that, I don't know, let's say because it's Tuesday, that there's another OpenSSL vulnerability and third-party containers are abounding in your environment. Some you built yourself, some you've taken from public, some you don't really know where they necessarily came from. Which ones are patched? How do you patch them? Relatively recently, it was reported that something like 70% of the images earlier this year on Docker Hub were still vulnerable to Heartbleed or shell shock. Now, Docker, to their credit, has recently released a security scanning service for free, which does help address this, and it's awesome. But I'm not convinced this is going to say, well, that checks the security box and there's no other concerns here. For example, I still run a container that for my Git talks that has not been updated in a year because it's perfect for what I do. And I guarantee you someone somewhere is doing something horrific with it in a production environment. So you wind up with a giant list of things, ultimately, that apply to running in production that don't apply nearly the same way when you're running in development mode. And these are all solvable things. I don't want to suggest in any way, shape, or form that it's not. But by the time that you've solved for all of these, it's highly likely that you've built something that looks an awful lot like a unicorn or possibly a donkey with a carrot strapped to its head. Because no one else is going to make the exact same technology decisions every step of the way, which means that you're going to be on your own. You don't get to be a full Stack Overflow developer anymore. You're going to have to be able to troubleshoot things yourself. And this really speaks to a great myth that I wanted to take the advantage of someone being foolish enough to give me a microphone to address. Specifically, there's this intrinsic belief throughout the industry that we believe that problem solving around container management and architecting for stupendous scale that Netflix, Google, Facebook, Twitter, et cetera, have all done, they've magically somewhere along the line figured out the right way to solve these problems. And that's simply not true. They've solved their problems. And their constraints that they work under aren't our constraints. When Netflix was moving into AWS at a stupendous scale, the management tools that AWS had to offer then were, to put it bluntly, terrible. So they had to build a lot of their own, things like Asgard, later in time, things like Spinnaker, a whole host of other projects. Now in 2016, the management tools are less terrible. I won't say awesome, but they're definitely usable. So maybe solving for these problems isn't what we should all be doing in our own individual companies. They don't tend to solve their own problem. They tend to solve their own problems, not the global problems here. And here at the end, we finally get to the point where why Docker is relevant to me, someone who specialized in configuration management for most of my career. Immutable infrastructure and configuration managed environments are not binaries. They're part of a spectrum, and virtually nobody is entirely on one end or the other. Is the world moving toward immutable? Absolutely. Does that mean configuration management's dying? Not even a little bit. After everything that I've demonstrated, that with challenges with getting Docker into a production-style environment, does anyone think this is going to be a quick cutover for anything that isn't greenfield? When you have a 10-year-old legacy application, just picking it up and dropping it into a Docker container is going to be straightforward? I mean, this is the beautiful thing about conferences, is the hallway tracks, where we get to talk to people about how they're solving specific problems. But there's a danger. Everyone likes talking about the really cool things they do. No one wants to talk about the 3 months they spent on something that turned into a complete failure. So all we're seeing, for a large extent, is people's highlight reels. People don't get to talk nearly as much about that terrible idea I had that I suggested that wound up getting an entire team of people fired when we couldn't deliver. I do want to give a quick shout out as well to Michael Ducey, who tweeted this original out after Julian drew it on a board. I didn't see this original one, so in the first version of this talk, I had no idea where it came from. The version that I saw looked a little different, which is in many ways more appropriate. Tyler Fitch out of Chef wound up helping me track down who it was so I could attribute it. So if anyone knows him, thank him for me. I appreciate it. There's just something about people who work at Chef that makes them willing to pitch in and volunteer. This is me. I want to thank you all for coming. I hope you enjoyed it. I know I've enjoyed being here, and I'm looking forward to Monday where we go back to work implementing Docker. Thank you.